My name is Kevin Weaver. In this continuing series of Level 5 SAT questions, we're going to look at another Level 5 question that is an algebra question. If x and y are positive integers and 1568 is equal to the quantity x to the 1/2 times y to the 1/5, all raised to the 10th, and z to the negative 2/3 is equal to 9, what could be the value of y times z to the negative 1? This is a case where you need to follow the exponent rules. From the original example of 1568 equals that quantity to the 10th, we want to use the product rule, so that x to the 1/5 times 10 would be x to the 5th, and y to the 1/5 times 10 would be y squared. If we break down 1568 into prime factors, use the x to the 5th and the y squared as suggestions. We need something to the 5th times something squared that would then result in a product of 1568. I would tend to start with the smallest prime, like a 2, and raise that to the 5th power, and then see what happens when 1568 is divided by 2 to the 5th. You would end up with 49, which means that y squared is 7 squared, which means that y is a 7. Even though x is a 2, we don't care because that's not part of the problem. We're trying to find y, 7, times z to the negative 1. The second part of the question indicated that z to the negative 2/3 is equal to 9. The negative exponents create fractions. So z to the negative 2/3 is 1 over z to the positive 2/3, which is equal to 9. If we took the reciprocal of both sides, or you decided to cross multiply and solve for z to the 2/3, it's equal to 1/9. Now, how do we find z? Well, we raise z to the 2/3 to the 3/2 power, and also the 1/9 to the 3/2 power, and we find that z is equal to 1 over 27. That's the square root of 1/9, and that result, 1/3, is cubed, 1 over 27. As a result, z to the negative 1 would be the reciprocal of 1 over 27, which is 27. And 27 multiplied by y, which we found earlier to be a 7, is 189. Answer D.